Space is our future, but space is also a deadly place with poisonous radiation and an increased risk of cancer. We're protected here on Earth thanks to our planet's magnetosphere, but is there a way to create an artificial magnetosphere and shield astronauts? With over half a century of experience sending humans into space, we've learned quite a bit about what it does to the human body. The microgravity weakens the bones, reduces muscles, and puts stress on the organs, but this can be partly compensated by exercise. Time spent in isolation or in close quarters with other astronauts can push people to the breaking point. But this isn't the first time we've learned to work in isolated and dangerous environments with other human beings. Being in space, away from the support of modern society, requires that astronauts have the skills, training, and communication with Earth to deal with medical emergencies, hardware failures, and the inevitable hostile xenomorphs, whether it's a stand-up fight or another bug hunt. But there's one risk that's always going to be there when humans travel out into the solar system: radiation. Powerful solar storms can kill astronauts in days, but even the ongoing background radiation of the universe is going to be increasing their risk of getting cancer through their entire lives. We're protected here on Earth by our planet's magnetosphere, the magnetic shell that surrounds our world, redirecting high-energy particles so they can't reach the surface. Earth is protected, and so is Jupiter, but good luck living down on the cloud tops of that gas bag. Unfortunately, the outer space places where we'd really like to live, the Moon, Mars, or rotating space stations and Lagrange points, have no such protection. This leads our imaginations to wonder, could we generate an artificial magnetosphere to protect astronauts and space colonists? Magnets keep photos and shopping lists stuck to my refrigerator. How hard could it be? There are three kinds of radiation that space travelers will need to be concerned about. The first is galactic cosmic radiation, or GCR. These are clouds of high-energy particles thought to come from supernovae. They've been traveling for millions or even billions of years for the opportunity to smash up your DNA. Although the amount of radiation is fairly low, the individual particles have incredibly high energy and can punch through existing spacecraft shielding. And they can come from any direction in the sky. When astronauts close their eyes, they see flashes of light, cosmic rays zapping through their retinas. The second kind is known as trap radiation. These are particles which have been trapped in a magnetic field, like the Earth's Van Allen belts or Jupiter's magnetosphere. Although this is a big problem when you're in this region, they don't extend far. The third kind is energetic particles released by the sun during solar storms. These particles are low energy, and spacecraft can provide shielding to protect astronauts. You've probably heard the term RADS for radiation exposure, but scientists now use a term known as sieverts or millisieverts for 1,000th of a sievert. In the short term, if you get half a sievert of exposure or 500 millisieverts, then you'll experience the symptoms of acute radiation poisoning. We're talking fatigue, nausea, vomiting, seizures, and eventually death. Get a few sieverts in one dose, and death is the likely outcome. But the radiation can also harm you over your lifetime. For every additional sievert you experience, you face a 5% increase in the risk of developing cancer in the future. NASA's policy is that an astronaut can't get more than a 3% increased risk of cancer as part of their career. Any mission that would give an astronaut that kind of risk won't be approved. Astronauts in low Earth orbit accumulate 10 times the amount of radiation you get down here on the surface. And astronauts beyond the Earth will experience 10 times the radiation of a low Earth orbit mission. During its flight to Mars, NASA's Curiosity rover measured the amount of radiation dosage it was experiencing through the trip. According to the radiation assessment detector instrument on board Curiosity, it experienced an average of 1.8 millisieverts of radiation per day during its voyage. The majority were galactic cosmic rays, high-energy particles from other stars in the universe, while only 5% of that came from the sun, thanks to the lower activity of our star during this period. According to NASA, it's like getting a full CT scan every 5 or 6 days. But the bottom line is that for a human trip to Mars lasting as much as 1,000 days, the risk of cancer goes beyond NASA's policy. And for humans living on Mars and in space, a human will experience much worse, not to mention lethal doses during powerful solar storms. During the Apollo era, NASA just sent astronauts astronauts quickly through the magnetosphere to minimize the radiation dose from the trapped radiation surrounding the planet. And they'll use the same technique for future missions out into deep space. Beyond that, NASA looks at physically shielding the astronauts. The Orion crew capsule, for example, will be equipped with an instrument called the Hybrid Electronic Radiation Assessor, or HERA. It will give the astronauts a warning when there's an increase of solar radiation so they can protect themselves. They'll have about an hour to create a temporary shield made from storage bags and supplies on board Orion. They need to stay inside their homemade fort for up to 24 hours until the storm passes. Now I'm sure you're thinking, let's just surround the spacecraft with an artificial magnetosphere. There we go, problem solved. Of course, NASA has thought of this, and they've been struggling to implement this idea for over 40 years. Wernher von Braun designed a hypothetical spaceship containing a solenoid that would direct an electric field to generate an artificial magnetosphere. You've probably done this experiment in your school science class. If you run electricity through a wire, it generates a magnetic field. The more electricity you pump through the wire, the stronger the field, and this is called an electric dipole. The problem is that the strength of a magnetic field produced by an electric dipole drops by the inverse of the cube of the distance. In other words, the bigger the field, the more energy you need. And that gets expensive fast. But in the last few decades, amazing new materials called superconductors have been developed, providing a way that electricity can move through material with almost no energy loss. And they work best at cold temperatures, and space is generally pretty cold. So in theory, using a superconducting wire, it should be possible to generate a powerful enough magnetic field using only a few dozen kilowatts of power. That's a lot, but within the energy budget of a spacecraft. Back in 2011, NASA's Innovative Advanced Concepts Group awarded a contract to Advanced Magnet Lab for the development of an artificial magnetosphere. They proposed surrounding a spacecraft with expandable superconducting coils. Once charged up, the magnetic coils would expand around the spacecraft, protecting it from the various forms of radiation. In the end, the team concluded that although this technology is feasible, it's not ready. The state-of-the-art in superconducting materials weren't light enough to provide better protection over just piling up junk in the spacecraft. In other words, it's still better to just go surrounding yourself with your own food, water, and other supplies than to try to generate an artificial magnetic field. The European Space Agency thinks it's on track to develop an artificial magnetosphere thanks to a collaboration with CERN. And if anybody knows how to direct charge particles, it'll be the folks operating the Large Hadron Collider. They worked on the European Space Radiation Superconducting Shield project known as SR2S. It used a superconducting wire made of magnesium diboride coiled up. And by running electricity through the coil, it should be capable of producing a magnetic field 3,000 times stronger than the Earth's magnetic field, providing a bubble of magnetic safety 10 meters across. This would allow the astronauts to be inside the spaceship or even perform spacewalks outside within the protective bubble, all the while protected from space radiation. And we last heard a flurry of announcements about this technology in 2015, and I reached out to the director of the project, Dr. Roberto Battiston, who is also the director of the Italian Space Agency. And according to Dr. Battiston, the experiments went well, and the next step is to investigate higher temperature superconductors, but nothing that's ready to protect astronauts. Instead of protecting a single spaceship though, what if you could protect an entire planet? At the recent Planetary Science Division meeting held in Washington, D.C., a team of researchers proposed a pretty clever way to protect Mars from solar radiation. Instead of trying to surround the planet in some kind of artificial magnetosphere, they suggested that you could get the same effect by positioning a smaller shield at the Sun-Mars L1 Lagrange point. This is the point in between the Sun and Mars where very little fuel is needed to keep a spacecraft in place. With the right electric charge on the shielding spacecraft, it would generate an artificial magnetosphere that blocks the radiation that would reach Mars. Imagine a rock in a river with a calm trail behind it. It gets even better. This trail would block the solar wind from reaching Mars, which blasts away its atmosphere into space over billions of years. So with this shield in place, volcanic outgassing would naturally thicken the density of the atmosphere and increase temperatures on Mars by an average of 4 degrees Celsius. This would be enough to melt the carbon dioxide polar caps contributing to a greenhouse effect, warming the planet even more. Future Mars colonists would enjoy the decreased solar radiation and the steadily thickening atmosphere on the red planet. Unfortunately, this technology would only protect against solar radiation. It wouldn't help against the galactic cosmic radiation. In a moment, I'm going to talk about a cool proposal that would create an artificial magnetosphere on the surface of Mars. But first, I'd like to thank Jordan Barnes, Sindra Svensby, Amon Carlson, and the rest of our 813 patrons for their generous support. If you love what we're doing and you want to get in on the action, head over to patreon.com/universe today. Although the L1 shield will protect lunar or Martian colonists from solar radiation, it doesn't help with the galactic cosmic radiation. In order to protect against that threat, a researcher from Italy named Marco Peroni has developed a solution, planting a huge wired donut into the ground and running electricity through it. He proposes building a huge solenoid or donut that would be embedded in the bedrock of the moon or Mars, and although the full solenoid will be up to 1 kilometer below the surface, part of the ring would pass above the ground, providing a protected area for the colony. The solenoid would consist of huge cables that would pass an electric current, and by doing so, generate a powerful magnetic field that protects the colony from both cosmic and solar radiation. The cables would also provide the structure for the roof of the colony for a micrometeorite shield, which would block a view straight up, but would be open to space on the sides. Below this protective shield, the actual colony would be housed in smaller domes, fully protected from the radiation coming from space. It would be an enormous undertaking, but once completed, would give colonists a safe place to live and work on the surface of another world. Although it sounds like an easy enough idea, the task of creating an artificial magnetic field is actually quite challenging. It requires advances in harnessing superconducting materials, and it could still be a long time before anyone cracks this, so that a future astronaut commander can just say, "Shields up," when a solar storm is passing by. How do you feel about the risks? Would you be willing to increase your chances of getting cancer if it meant being one of the first humans to go to Mars? Let me know your thoughts in the comments. Time for a playlist all about space radiation and how we can protect ourselves from it when we journey beyond Earth. Marco Durante talks about the dangers of space radiation and what can be done about it. Curious Droid talks about deep space travel and space radiation. Dr. Ian O'Neill talks about a space shield, a longer lecture from NASA about space habitats and radiation protection, and finally, Bill Nye and astronaut Mike Massimo talk about space radiation and electromagnetic shields. And that starts right now. Instead of just protecting a single spaceship though,